Sketch and Sketch is an attempt to combine programmatic and direct manipulation within a single SVG editor. In Sketch and Sketch, the user writes a program that generates an output SVG design. The editor displays the program and its output side by side. The programming language in Sketch and Sketch is a little untyped language we call Little. If you have programmed in functional languages like Racket, ML, Haskell, or Elm, the Little language will look pretty familiar, albeit with fewer bells and whistles. The result of a Little program is a list of SVG shapes that gets rendered in the canvas on the right. We can start by calling a library function called rect to draw a simple rectangle based on a few parameters. When we hit the Run Code button, Sketch and Sketch runs our program and draws the resulting SVG shapes in the canvas on the right. Let's now add some additional shapes. In the current version of Sketch and Sketch, there are no GUI tools for drawing new shapes, so we hit the Edit Code button to switch back into editing mode. We can copy our function call, paste it a couple of times, and change a few parameters to style the shapes differently. Whenever we run a program, Sketch and Sketch switches from editing mode into what we call live mode. In live mode, we can directly manipulate the objects in the canvas, much like we would in a direct manipulation editor. This is often easier than switching back into editing mode, changing some parameters, and running the program again. Notice that, while we manipulate shapes in live mode, Sketch and Sketch infers updates to the program in order to match our changes to the canvas. See those constants that are highlighted in yellow and green? A yellow highlight identifies a number in the program that Sketch and Sketch will change if we drag the object currently under the cursor. When we are in the middle of dragging this object, the green highlight identifies the change that Sketch and Sketch makes to the number in order to match our mouse manipulations. If we go back into editing mode and then rerun the program, we get the same results that we had from direct manipulation. As in most direct manipulation editors, different areas of a shape affect different attributes. We call these areas zones in Sketch and Sketch. To get a better sense of what zones are attached to each shape, we can click the Zones button to show them explicitly. By default, the zones are hidden, but they are still there. Notice that each rectangle has 9 inner zones, each of which controls different attributes of the rectangle. For example, the interior zone changes the x and y coordinates, the right edge zone changes the width parameter, and the bottom right corner zone changes the width and height parameters. Each of the different kinds of SVG shapes comes with different kinds of zones. In case you were wondering, the result of a Little program really is just an SVG definition, rendered in our editor with special support for synchronizing its visual representation with the program that generated it. If we want to export our design, we can toggle the output mode to display the raw SVG instead, which we can then copy and paste into any other SVG editor. So far, we have defined 3 rectangles that, although similar, are defined and manipulated individually. Now let's turn this design into a more structured, repetitive pattern. In particular, let's rewrite our program so that it draws the same rectangle 3 times, spacing them evenly along the x-axis. One way to accomplish this is to use a common functional programming operation called map to apply a single drawing function to a list of arguments. In this case, we define a drawing function called drawI that takes an integer index I as an argument and draws the ith box. Notice how we use the same constants to specify the height, width, and y positions of all the boxes. To emphasize the purpose of these constants, we can define names for them. Now, when we rerun the program, we see that our boxes are evenly spaced. With this programmatic setup, it's easy to alter the number of boxes by adding additional index parameters. The number of boxes is a parameter of our design, so let's introduce a name for this number. Generating the list of numbers between 0 and n-1 is common, so the little library provides a function called 02 to do just this. Now that we have reworked our program to capture the high-level intent of our design, let's see how we can directly manipulate the output. When we drag the right edge of a box, notice how all boxes are updated simultaneously. This is because the width of the box we manipulated is defined directly in terms of the w variable in our program. So, Sketch and Sketch figures that the only reasonable thing to do is to change the value of w in order to match our changes. This program update immediately affects the width of all other boxes, which is precisely what we had set up our program to do. Similar updates are inferred when we directly manipulate other zones. We use the term simple update to refer to situations like this, where a single number in the program controls an attribute in the output. Simple updates are, well, simple for Sketch and Sketch to resolve. Matters are trickier when multiple values in the program affect an attribute in the output. Consider the x attributes of the boxes, all of which are computed by the expression x0 plus I times sep. Because the runtime value of this attribute for the first box is just equal to x0, dragging the first box is a simple update for Sketch and Sketch to resolve. By changing x0, all boxes are translated in unison. When dragging any box besides the first one, however, there are multiple numbers that factor in to the computation of xi, namely x0 and sep. When hovering over the interior of these boxes, notice how these two numbers are highlighted. When there are multiple numbers that can be changed, we call this an ambiguous update, as opposed to the simple updates we saw earlier. There are several ways to deal with ambiguities in Sketch and Sketch. For now, we will mention just one. We can turn an ambiguous update into a simple one by annotating numbers in our program as frozen, which means that Sketch and Sketch should not, under any circumstances, modify them. Adding an exclamation point after a number freezes that number. For example, say that we are happy with the spacing between boxes, so we freeze this sep constant. Now, even though sep still affects the x position of all boxes except the first, Sketch and Sketch has only the option of changing the x0 value. So, when dragging any of the boxes, x0 is changed, and thus the entire group is translated. Alternatively, we can unfreeze sep and freeze x0 instead. And now all boxes can be dragged in order to change sep. If we freeze both x0 and sep, we can no longer affect the x positions in any way, but we can still manipulate other attributes like width and height. Freezing constants is one way to deal with ambiguous updates in Sketch and Sketch. Later on, we'll see other ways. To recap, in this section we talked about Little, the programming language inside Sketch and Sketch used to create SVG designs. We saw how Sketch and Sketch provides two interaction modes, editing mode for directly editing the source program, and live mode for directly manipulating the output generated by the source program. We saw examples where direct manipulation in live mode led to simple updates to the program, and we saw how to freeze numbers in the program in order to turn ambiguous updates into simple ones.